Suppose any function is in this form f of ax plus b, then we can write it as 1 by a phi ax plus b. F of ax plus b into dx can be written as 1 by a phi ax plus b plus b. 1 by x is nothing but log x. We have ax plus b, so we write it as 1 by a log x. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In the last session, we have learnt how to evaluate the integrals of the particular function when you have already learnt all the standard results of the exponential as well as the trigonometric function. So in today's session, we are going to learn a method of integration called integration by substitution. Here, whenever the function is given, we can simplify it. Whenever the trigonometric functions are given, we can use any one of the compound angle, multiple angle or transformation formulas to simplify it. Then we can apply the integrals. Similarly, any polynomial or exponential functions have learned. We have already learned many rules for exponential, log functions and polynomial function. With the help of all those substitution, we can simplify the given function, then we can apply the integration for the given function. So let's start today's session, integration by substitution. So here we have a theorem. They have given integral of f of x dx is some phi of x plus c1. So here, suppose any function is given, you have already learned integration of sine x is minus cos x, integration of cos x is sine x, integration of cosecant square x is minus cot x, integration of secant into tan is secant x. Like that, we have integration of a function which gives its antiderivative. Suppose any function is in this form f of ax plus b, then we can write it as 1 by a phi ax plus b. For example, if they give you integration of sine ax plus b into dx, then we can write it as 1 by a, what is integration of sine? Cos x. So therefore this can be written as minus 1 by a cos ax plus b. That means the antiderivative of the function is same. If it is phi of x, then it is in the form of phi of x only, but only changes you have constant 1 by a. So if they have given integration of secant square ax plus b into dx, then we can write what is integration of secant square? It is tan. But now it is in the form of secant square ax plus b. So I will write it as tan ax plus b. Along with tan ax plus b, we have a constant 1 by a with its integral constant. Like this, any function of this form can be written in the form of its antiderivative with only one extra, that is 1 by a into phi of ax plus b, which is the antiderivative of the given function. Example, 1 by ax plus b into dx can be written as 1 by a log ax plus b. Because 1 by x is nothing but log x, we have ax plus b, so we write it as 1 by a log a. Suppose you have integration of e power ax plus b, then this can be written as 1 by a e power ax plus b. E power x is e power x itself. Since you have ax plus b, you write it as 1 by a. Suppose you have a bx plus c into dx. We know integration of a power x is a power x by log a. So this can be written as a power x bx plus c divided by log a. But bx plus c, write it as 1 by b. Like this, any of the function of this form can be written as 1 by a of its antiderivative. The second theorem says here, so any function with its derivative is given, then we can write the function directly as log f of x plus c. For example, if they have given integration of sin x by cos x into dx. So here clearly if I take f of x is equal to cos x, then f dash of x is sin x. So now this is in the form of f dash of x by f of x. Whenever the function and its derivative is given inside the integral, it can be directly written as log f of x plus c. So here what is this? Log cos of x plus c. Like this. Now I will take one more example for this time. Suppose they have given integration of 1 by x log x into dx. Let me take log x as f of x. If f of x is equal to log x, then derive it. What is derivative of log x? 1 by x. So therefore, if you take log x as f of x, then 1 by x can be written as f dash of x into dx. So this can be written as log of log x. So therefore, I can directly write the value as log of log x plus c. So this is what the theorem 2 states. That is, integration of a function with its derivative can be written in the form of log f of x. Next theorem we have a function in the form of n, f of x whole to the power n into f dash of x into dx. Suppose you have any function with power n along with its derivative, then the function can be written in the form of f of x to the power n plus 1 divided by n plus 1. So this is what the theorem 3 says. For example, suppose you have a function log x square divided by x into dx. So now let me take f of x as log x. Then what is f dash of x? F dash of x is 1 by x. So you have a function log x with the power along with its derivative f dash of x. So here this can be written as f of x whole square. 1 by x into dx can be written as f dash of x into dx. So when you have a function of this form, as the rule says, you can add the power with 1. So this becomes f of x to the power 3 by 3. So what is f of x? It is log. So log x whole to the power cube divided by 3. So like this, we can write the given function in this form. So in general, all these theorem helps us to get a type of integration of the form f of ax plus b into dx can be written as 1 by a phi ax plus b plus b. So integration of sin ax plus b is 1 by a cos ax plus b. Integration of cosecant ax plus b cot ax plus b can be written as minus cosecant ax plus b. Integration of ax plus b whole power n can be written as 1 by a ax plus b to the power n plus 1 by n plus 1. Similarly, if you have it in the form of 1 by x, it can be written as log x. 1 by ax plus b means 1 by a log ax plus b. So any function of this form can be written with its antiderivative with 1 by a along with the integration constant. So along with some of the result, we have some standard results also. So what are the some standard results? That is, we can write integration of tan x dx as log of secant x. Next, integration of cot x dx can be written as log of sin x. Next, integration of secant x can also be written as log of secant x plus tan x. Next, integration of cosecant x dx can be written as log of cosecant x minus cot x. This can also be written as log of tan of x by 2 plus pi by 4. And this integration of cosecant can also be written as log of tan x by 2. So these are some standard results which you can use while solving some integrals. Integration of tan x is log of secant x. Integration of cot x is log of sin x. Integration of secant x is log secant x plus tan x or log tan x by 2 plus pi by 4. Integration of cosecant x is log of cosecant x minus cot x, or you can write it as log of tan x by 2. So let's take few problems. Integrate the following functions with respect to x. Given 3x plus 5 whole to the power square. So any function of the form ax plus b can be written with the same derivative. So we know if you have x power n, integration of x power n is x power n plus 1 by n plus 1. So if you have this in the form of ax plus b whole to the power n, then integration of ax plus b whole power n can be written as 1 by ax plus b whole to the power n plus 1 by n plus 1. The same rule which we use for the given function with variable x. So this integration with dx can be written as 1 by 3x plus 5 whole to the power 2 divided by 2 plus 1. What is 2 plus 1? 3. 3 3s are 9. So the value is 1 by 9, 3x plus 5, here plus 1 whole cube. So this is the given value of the integration. Next, we have e power 5x plus 7. So integration of e power ax plus b into dx can be written as 1 by e power ax plus b plus c. So apply the rule here. So integration of e power 5x plus 7 into dx can be written as a value is 5 here. So it is 1 by 5 e power 5x plus 7 plus c. Next question. Cosecant square 5x minus 3. We know integration of cosecant square is minus cot x. Now this is in the form of ax plus b. So therefore integration of cosecant square ax plus b is nothing but minus 1 by a cot ax plus b plus c. So this is dx with respect to dx. Cosecant square is minus cot. So it is in the form of ax plus b. So it should be 1 by a form of ax plus b. So therefore, if you integrate this with respect to dx, I can write this as minus 1 by 5 cot 5x minus 3 plus c. So the value of or the sign of b doesn't changes the function because we need only a value. So it is 1 by a. Next, secant 2x plus 3 tan 2x plus 3. We know integration of secant x tan x dx is nothing but secant x. So therefore, here if you apply integration of secant into tan into dx, this can be written as secant 2x plus 3 plus c. Since this is in the form of ax plus b, we will write 1 by a. So this is the value. Next question, tan square 3 minus 2x. So we know that tan square can be written as secant square minus 1. So let's convert this. This can be written as secant square 3 minus 2x minus 1. Now this is in the form of b minus ax. So value of a is here minus 2. So therefore remember integration of secant square 3 minus 2x minus 1. This is in the form of b minus ax. So this implies value of a is minus 2 here. So therefore you are integrating the function with respect to x. Integration of secant square x is tan. So this can be written as tan 3 minus 2x. 1 by a can be written as minus 1 by 2. Next you have minus integration of 1 into dx is x plus c. Next question, sine cubics. So remember the formula, sine 3x can be written as 3 sine x minus 4 sine cubics. So replace this 4 sine cubics can be written as 3 sine x minus sine 3x, or sine cubics can be written as 3 sine x minus sine 3x divided by 4. So replace sine cube x by this formula. So integration of sine cube x dx can be written as integration of 3 sine x minus sine 3x whole divided by 4 into dx. Now here we have integrated separately. Take 4. So this becomes 3 by 4 integration of sine x dx. Similarly here 1 by 4 integration of sine 3x dx. Now this is only in the form of sine ax. B is 0. So therefore this can be written as minus 1 by a cos ax. So here now 3 by 4 integration of sine x is minus cos x. Next minus 1 by 4 integration of sine 3x is cos 3x along with 1 by 3 minus cos 3x. So plus c. So therefore I can write this as minus 3 by 4 cos x plus 1 by 12 cos 3x plus c. Next question, cos 5x cos 3x. So here we have an integral of a transformation formula. This is in the form of cos c plus cos d. So cos c cos d can be written as half cos c plus d plus cos c minus d. So using this formula here, cos 5x cos 3x can be written as half. I will take outside the integral. I'll take only this part, cos c plus d cos c minus d, which becomes cos 5x plus 3x plus cos 5x minus 3x into dx, which becomes half integration of cos 8x plus cos 2x into dx. I'll take half outside. So integration of cos ax plus b form, which is nothing but sin ax plus b. Here b value is 0, we have only a. So I can write it as 1 by a sin ax. So this can be written as 1 by 8 sin 8x plus 1 by 2 sin 2x plus c. So this is the value of the given integral. Next, here we have 1 minus sin x. So here I'll take a substitution of half angle formula. So sin x can be written as 2 sin x by 2 cos x by 2. In the place of 1, I'll write sin square x by 2 plus cos square x by 2, because that is equal to 1. So this is to simplify the given value. So if I substitute here, this becomes sin square x by 2 plus cos square x by 2 minus 2 sin x by 2 cos x by 2 under the square root into dx. Now this can be in the form of a square plus b square minus 2ab, which can be written as a minus b whole square. So therefore this can be written as sin x by 2 minus cos x by 2 whole square under the square root into dx. So square and square root can be removed here. So we are left with integration of sin x by 2 minus cos x by 2 into dx. Now this is in the form of sin ax. So integral of sin ax is minus cos ax by a. So the value of a is here half. So here this becomes minus cos x by 2 by a is half. And here minus integration of cos is sine divided by a. So value of a is 2. So we can take minus 2 outside. Half, when it goes to the numerator, it becomes 2 here. Also, we can take minus as a common. So the value can be written as minus 2 into cos x by 2 plus sine x by 2. So this is the value of the given integral. So you can write the integration constant along with it. Next one, 1 plus cos x, 1 minus cos x. Again using half angle formula. So we know that 1 minus cos 2x is 2 sine square x. So 1 minus cos x can be written as 2 sine square x by 2. Half angle formula. And 1 plus cos x can be written as 2 cos square x by 2. So replacing here, integration of 1 plus cos x is 2 cos square x by 2 divided by 2 sine square x by 2 into dx. 2 get cancels. Cos square sine square can be written as integration of cot square x by 2 into dx. So cot square can be written as cosecant square x minus 1. So therefore this is integration of cosecant square x by 2 minus 1 into dx. Now this is in the form of cosecant ax form. So which can be written as minus 1 by a cot x form. So what is integration of cosecant square x? It is cot x by 2 and divided by 1 by 2. When it goes to the numerator, it becomes minus 2. Next, what is integration of 1 into dx? It is minus x plus c. So this is the value of the given integral. So I hope you understood how we can substitute a given function to simplify it and to convert the functions of the form f of ax plus b to 1 by a phi of ax plus b. We will take few more problems to solve the integrals in our next session. Until then, keep watching, keep learning, keep exploring. Thank you.